Hey everyone, and welcome back to the channel. If you're passionate about understanding our amazing planet, then you've landed in the right place today. We're diving deep into a topic that might sound a little cracky, but trust me, it's incredibly fascinating and super important for geologists worldwide. We're talking about geological cracks. Not just any crack, but those significant fissures in the Earth's surface that scientists are keeping a very close eye on. Now, when we hear crack in the Earth, our minds might immediately jump to dramatic Hollywood movies or catastrophic events, but the reality is often much more nuanced and equally as thrilling from a scientific perspective. These cracks can be signals of incredibly powerful forces at play beneath our feet. For science students and curious minds, understanding these phenomena isn't just about memorizing facts, it's about appreciating the dynamic, ever-changing nature of our home planet. So why are geologists so utterly captivated by these movements? Well, it's not just curiosity. Monitoring these cracks is crucial for several reasons. Firstly, they act as telltale signs of geological stress. Think of it like a tiny stress fracture appearing in a piece of metal before it eventually breaks. The Earth works on a much grander scale, but the principle is similar. These cracks can indicate areas where tectonic plates are pulling apart, pushing together or grinding past each other. They're literally windows into the colossal forces shaping our continents and oceans. Secondly, and perhaps most importantly for human populations, these cracks can be precursors or indicators of potential natural hazards. We're talking about things like landslides, sinkholes, and even in some cases, seismic activity like earthquakes. By meticulously tracking the changes in these cracks, how wide they get, how deep and how quickly they're moving, geologists can gather vital data. This data is then fed into complex models that help us understand the risks and potentially even provide early warnings to communities that might be in harm's way. It's a testament to how science directly contributes to public safety and resilience. Let's break down how geologists actually do this monitoring. It's not just someone standing there with a tape measure, though simple measurements can be a starting point. They employ a whole arsenal of sophisticated tools and techniques. We're talking about everything from traditional surveying methods, using incredibly precise GPS systems that can detect movements down to mere millimeters, to cutting-edge satellite imagery. Satellites equipped with radar like those using InSAR technology can literally map ground deformation over vast areas from space. Imagine being able to see the Earth's surface subtly bulging or sinking from hundreds of kilometers up. It's mind-blowing. They also use ground-based sensors, such as strainmeters and tiltmeters, which are embedded directly into the Earth near these cracks. These instruments are incredibly sensitive, designed to pick up even the slightest changes in the Earth's crustal strain or tilt. It's like giving the Earth a nervous system, allowing scientists to feel its subtle shifts and tremors. The data from all these different sources is then collected, analyzed, and often combined to create a comprehensive picture of what's happening beneath the surface. It's a multifaceted approach, combining boots-on-the-ground fieldwork with advanced remote sensing. But it's not just about the technology. A significant part of a geologist's work involves keen observation and understanding the local geology. They examine the rock types, the presence of water, and the historical record of movement in an area. Sometimes, a crack might be relatively harmless, a result of soil drying out or minor subsidence. Other times, it could be a manifestation of much deeper, more significant geological processes. Distinguishing between these scenarios requires deep expertise and a detective-like approach to problem solving. Consider the famous example of the East African Rift Valley. This is one of the most dynamic geological features on Earth, a massive crack where the African continent is slowly but surely splitting apart. Geologists here are not just monitoring one crack, but a whole network of faults and fissures. The data they collect is invaluable for understanding plate tectonics in real time, essentially watching a continent being born, or reborn, before their eyes. The insights gained here contribute massively to our global understanding of how continents form and evolve over millions of years. And it's not always about massive continental shifts. Sometimes, these cracks are very localized and still require intense scrutiny. Take areas prone to landslides, for instance. A crack appearing on a hillside after heavy rainfall could be an early warning sign of an impending slope failure. Geologists and geotechnical engineers work together to assess these situations, often deploying emergency monitoring equipment to track movement second by second. This can give communities precious time to evacuate, potentially saving lives and mitigating damage. So when we talk about geologists closely monitoring the crack for further movement, it's not a simple passive act. It's an active scientific endeavor that involves continuous observation, cutting-edge technology, sophisticated data analysis, and a profound understanding of our planet's inner workings. It's about being proactive, understanding risks, and ultimately, making our communities safer and more resilient in the face of Earth's powerful forces. It's a powerful reminder that our planet is a living, breathing entity, constantly changing and evolving. And the geologists are its vigilant doctors, listening to its heartbeats, tracking its movements, and helping us understand its incredible story. For any aspiring scientists out there, this field offers endless opportunities for discovery, problem-solving, and making a real-world impact. Thank you so much for joining me today on this deep dive into geological monitoring. I hope you found this exploration as fascinating as I do. If you enjoyed learning about how scientists keep an eye on our planet's movements, please hit that like button, share this video with your fellow science enthusiasts, and don't forget to subscribe to the channel for more educational content like this. Your support helps us keep exploring the wonders of science together. See you in the next video.